let us start. I hope so. I am live. Yep, I am live. Yes. Okay, guys, you can see me, right? Hello, guys. Welcome back to Coders Arcade. I hope so that I am visible. I hope so. Everything is fine. Camera. Everything is fine. Up. It is exactly perfect. There is no issue with the camera. I hope so. Okay, guys. Alright, so we are here now, guys. So we'll start now. I guess so. Yep, let us start. So hey guys, welcome back to Coders Arcade. This is Ashank David, and in today's video we are going to continue our DSA live sessions for placements. So what we are going to learn in this placement session? We are going to learn about, in the last session what did we learn? We did our searching and sorting algorithm. Now in today's class we will be continuing the concept of trees, and today we are going to learn about a new tree that everyone has seen till now, by now in the thumbnail, and that is red and black tree. It's a very important data structure concept. It is a type of a tree, just like how AVL tree works. Very similar to that, this tree is also working the same exact thing. So let us talk about that really quick, and without any further ado, let's start. This is Ashank David. Let's start the live session. Now before I start with this live session, I would like to just tell you and ask you about sharing this live stream as much as possible, because if you share this live stream, this stream will go on to those people also who really want to learn about DSA for all for free, and this is available in YouTube. So please share this live stream as much as possible, guys. Well, without any further ado, let's get right into the topic, guys. Alright, let us start. So today's concept that we are gonna work around with is gonna be red and black tree. So let's see. So we are into the session, guys. I hope so. People are joining. Okay, 2 people are there. Let us start. So today we are gonna talk about red and black tree. Red and black tree. A very important concept. If you are new to the tree concept, this is gonna be a very advanced concept for you. So for those people who have not understood about trees concept, please go ahead and watch our previous sessions. There I have explained about the trees concept in a very depth. So without any further ado, let's get right into the topic. Just few sessions back we have done and discussed about the trees concept. Okay, red and black tree. Now what exactly is this? Of course, as the name suggests, there will be 2 nodes. One is the red node, and I cannot draw the black color on the blackboard, so I'm gonna take white as the black. Okay, guys, imagine, because I'll not be able to take the black color in the blackboard, so I'll be using white as our black node. Okay, so there are 2 things, the red node and the black node. Well, there are no strict rules regarding red and black nodes. Actually, there are no strict rules regarding how the tree is going to work. There are some set of rules that you just need to follow, and if you follow those rules, it is going to be very easy. This is in fact easier than AVL trees. Speaking of AVL tree, did you get some hint Yes, this red and black tree concept works really very simple and similar to AVL tree. What does the AVL tree does? Go back my 2 sessions back and you will understand about AVL trees. I have already covered AVL trees, so link in the description below. I will be putting that later on. So if you don't have watched that video yet, please go ahead and watch that and come to this video, because this is a very similar concept to AVL trees. Speaking of AVL trees, what were AVL trees? Self-balancing tree. AVL was a self-balancing tree. Well, you guessed right. Red and black tree also does the same exact thing. It balances itself automatically and you don't have to worry about the balancing part. Understood? So, how does it work? Let us see. So, in AVL, I will write in AVL. What is the full form of AVL? Adelson and Velsky Landis tree. Adelson, Velsky and Landis tree. These are the 3 people, as I have told you. If you have not watched that video, go ahead and watch that video and come. Well, in AVL trees, it was also self-balancing. What was self-balancing stuff? Balancing. So, what was happening in this self-balancing? The word here, self-balancing, means the difference between the left and right subtree height, or in this case you can say depth of a particular branch can only be in between what? 1 to minus, or in this case if I say it like that, I would say -1 to +1. Okay, -1 to +1. What exactly is this, guys? We have understood this. That let us say if this is a tree, is it a balanced tree? Yes, it is a balanced tree, because you see on the left sub height and right subtree height, the left subtree height and the right subtree height has the same exact depth or same exact length. If I do a difference, here 1 and here also 1, I am talking about the nodes in the depth of the subtree, and when we are saying 1 and 1 at both the sides, that means this tree is a balanced tree. How? Because 1 minus 1 is equals to 0. So, the difference that comes between the height of both the trees shall be 1 or 0 or -1. It cannot be even lesser than -1. It can only be minimum to minimum -1, or it can be 1 positive. I hope so that this is very much clear. Hold on, let me just click or button onto my camera, otherwise my camera will shut down again. As you guys already know, you guys have been attending my live stream from a long time, and yeah, I am the only one who is operating the camera alone here. So yeah, I hope so you have got my point, guys. Correct. Apart from it, and we have understood this. This was the major property. This was the only major property. -1, 1 or 0. I hope so that this is very much clear. But what is the difference here between AVL and red and black? Now, this is very important for us to understand. Carefully listen to what I am gonna say now. Especially in case of red and black tree. In the case of red and black tree, especially in the case of red and black tree, we don't see the difference. We don't see the difference. Then what do we see? We see as obvious color, and the most popular colors are red and black. You guys know why I am writing black with white? Because it's a blackboard and I cannot write black on a blackboard, so that's why. I hope so that this is very much clear, right? So only these two colors are allowed. Only these two colors are allowed. Hope so that this is very much clear to all of you guys. Okay. But my question is, how the hell we will even think about it? You see that when we were doing AVL trees, we were able to get the differences. In this case, just look at when we were doing in this case, let us say if the height increases, let's say one more came here and now it is 2. So when it was 2, so I am doing 2 minus 1. 1 is coming from this side. What is the answer? 1. Still 1, it is acceptable. So this was acceptable, this was acceptable. If I say one more got added right here, it is still in the depth, it is just 2. So nothing will happen. If I say one more here, then this becomes an imbalanced tree. Why? Because you see here we have how many? Here we have 3 nodes, 1, 2, 3, and 3 minus 1 will become equals to 2, which is greater than 1, and the condition was either it should be minus 1 or 0 or positive 1. I hope so that this is very much clear. I hope so that this is very much clear. Understood this, guys? Now, on the other hand, I wrote here that especially in the case of red and black tree, we don't see the difference of minus 1, 0 or 1. That is seen strictly in AVL. But in the red and black tree, we don't see this property at all. Why? Because here that property has been changed now into the way that we see colors. There are some rules that you need to follow for seeing the colors, and that will decide if the tree is balanced or not. So let us, guys, go ahead and see that really quickly. There are some rules to this. Let us try to understand that. Okay. So in a red and black tree, just 2 colors are used, red and the black color is used. Now the first basic rules are the root is always black. The root is always black. So we will write the concept of black also. Okay. So this will be fixed black. The root will be black. Then the child can be either black or red. Black or red. Okay. But the condition is that red parent cannot have a red child. A red parent can have a black child. I hope so that this is very much clear to all of you. These are the basic properties which you should know. Okay. So root, it always be black, child black or red. Red parent will always have red, cannot have red children, but it can have a black children. Basic things. Talking about the basic stuff, let us see. We have a tree. This is a black node. This is a what? Black node. And this node later on can have 2, let us say let us start. Let us start from here. Let us say this is a black node. Let us say this is a black node, which is actually root. As I told you that root is always black. Okay. And now I said, let us do one insertion. One inserted node will come right here. One inserted node will come right here. Okay. And then let us say anywhere we can put. Remember that it is always being a BST. So BST property is maintained. You know what is BST property? Root left is small from the root and root's right is always greater than the right. I hope so that this is very much clear to all of you. Okay. So BST it is gonna be. Let us say first element came as, let us say this is, we are not taking the numbers will confuse you guys. So let us do one thing. Let us see, we have a node here and on the left hand side there is some node coming. Always remember, the inserted node will be always inserted as red. Always the inserted node will be inserted as the red. Root will always be black. Even if the root becomes red, later on the root should become black. But by default, when the node is gonna be created, it is gonna be red. How we will create that? In the node class, in the constructor of the node class, you can give the property of the color of a node equals to red by default. So any node that is created and gonna be inserted will have the same color red only. So remember this guys in your mind, root is black while the other inserted nodes are going to be red. Always remember, the last nodes which is null nodes are also going to be black. So root and the branch leaf nodes are also going to be always black. In this case, we will do some left to right rotation or right to left rotation, depends upon what you need to do and how you need to balance. In this case, we won't see, in unlike AVL tree, we used to see the balances is 1 or -1 or 0 balance. But in this case, we don't have to worry about that. In this case, we will not even check for -1, 0 or 1 condition. We will only check for either the color is red or black. Based off of that, we will make decision on how the tree height really works ultimately. Okay. So let us say you have done the first insertion and you have this node inserted, right? Okay, so the inserted node, as I have already told you from a basic rule, that inserted nodes are going to be right. So let us say on the left hand side of the tree, the red node is inserted. Remember that it is following BST. So whatever the node it is, either it is gonna be whatever, it will follow the BST rule, and our program is always being written in the BST rule. Okay. So BST rule is followed. So let us continue. Let's say this root the element goes here. Okay, as a new root, as a new node, that is red node. Okay, is the tree balanced? Of course, the tree is balanced. If because one is black and one is red, a black can have two children as red. Understood my point? This is also fine. Is the tree balanced? Yes, the tree is balanced, guys. Now let us say you have inserted one more node and it went right here. Now you see, red cannot have red child. Red cannot have red child. Remember this. In this case, this condition is false. This cannot happen. This cannot happen in this case. So what do we do from it? We will check this. We will check this. Is the root black? Yes. So can't I do some shift here? I can shift right here to this and this to the root. So the required tree would look like how? The required tree would look like how? It would next look like this. The red node comes up on the top. It can have one black node right here. So this will be shifted right here. So this will come right here, and so this node will come right here and this node can come right here. Understood my point? And what will happen? Here this right node can be created. Okay guys, so one I have shifted, so this will be shifted towards the right and this will be right shift done. So we cannot insert black nodes in the root. So we cannot insert black nodes. No, by default Ayush, the nodes which we are going to insert here, remember, the nodes which we are going to insert here are always going to be red by default. You cannot insert a black node. No condition for inserting the black node. It is clearly understood that we are trying to insert a node which is red. So by default the inserted node will be red. Okay, root will always be black. So in this case you see, after I shifted one here, what happened that this black node came right here and the red node went up there. Is it balanced? Is it violating the rules? Yes, it is violating the rules again, because this thing is happening. The same scenario is happening. Child, a red node cannot have a red child, but in this case red node is having a red child. But if you see guys, I always told you that the root node is always going to be black. So we will write a separate function which will contain any node which is sitting at the root is gonna be converted into black. Later on this node gets converted into black. I hope so that this is very much clear. Now I know this is a little bit silly concept, but this is how it works. Red and black tree is the concept. It's a very popular concept and this is not taught in all the colleges. Not in every college, in some colleges, but very few and very rare, but not in many colleges. In this case, this question is generally asked mostly in interviews from you and you have to answer it. And what you will do if you don't know? That is why you have to know about the concept and we have brought to you about this concept. Alright guys, so let us understand it again. What we have done, every time you do the insertion, again let us do one more time. Okay, let us do one more time. This is a black node. Now you inserted a red node. Now a black node can have two red nodes as children. That is absolutely fine. Okay. Now let us say one more node got added right over here. Then what will happen? In this case, this is violated. This is violation. So what will happen? This will go right here, this will come right here, and this will go right over here. So in this case, the next tree will look like this. Not right here, but right here. Right here. You got my point? When this came here, it went here and it went here. Okay. Now, what we will do, I have always told you that root will always be black. So automatically that will be converted to black. I hope so that this is very much clear. Understood this, guys? Like that. Okay. This is how it is gonna work. I have already explained you this once because these are our notes, so we are not repeated again and again in the notes because this is our notes. Okay. But I hope so that you have understood the concept. I have a PDF to show you in this case, and the PDF is very bright, right? Let me just adjust the settings for it. Wait guys, until you see. I hope so that now you are able to see what I am trying to show you. Okay guys, I hope so that this is very much clear. Okay, yeah, I hope that this is very much clear. Okay, focus onto the screen. Okay, not on my face, focus onto the screen. Okay, I hope so that I am also visible. Guys, let me also check from my side. I hope so that this is fairly visible. or shall I increase it a little bit? This much is better. And this much is much better actually. Okay. Yep. Better. Okay. Alright guys. So here you see we have this PDF, which I will put the link of this in the description for you guys. Okay. Simple insertion where we have no violations. Insertion with the recoloring when parent and uncle are red. Here we are talking about uncle and relationships between the nodes into the class. Okay. Insertion with rotation and recoloring when the parent is red but uncle is black. Okay, let us talk about it. Simple insertion where no violation is there. You see the root is 10. We have inserted the first node and the first node is gonna be inserted always as red. I have explained you, I have told you this many times by now that the concept is that the red node will always be 10. Like the new node will be always be taken as red. But then later on, as soon as it becomes red, as soon as it becomes the root, it will become black. It will be automatically converted into black. So here guys, don't think that the root node is by default black. No, it is also inserted for the first time as red, but then later on converted into black. I hope so that this is very much clear. So this node is black right now, and I have inserted 5. So on the left hand side it will go for 5, right? So 10 and 5 it went here, and new node is inserted as red. So this is R. Understood? Then is the tree balanced? Yeah, the tree is right now balanced because no consecutive red nodes and the root is black. For now this is clear. Then I said insert 20. The new node is red. So in this case the new node goes into the right. Now here in this case you see that there the parent, the main parent, which is 10, is black, but both the children are red and red. Okay. So no violations, tree is still balanced. A black node can have multiple red children also. So no problem, no worries, right? It is very much clear. Now in this case no violation is there. Okay. Now let us say in the same concept you inserted a new node which is 1. Now it will go right below onto the left hand side, and when it went here to the left hand side you saw that the red and red came both together, right here and right here, right. Okay. If I want to explain you this with the help of the diagram, I would create a diagram like this. So first node is black. Okay. Then I said, then the next node is here red. This is red. Okay. First is black. Okay. Then the next node is red, and then here also the next node is red. Okay, red, and one more red came right here. I hope so that this is very much clear. So this is a violation. This cannot happen. This is not possible. Red cannot have a red child, as we are understanding it from the very beginning. Understood? So now let us see what we will do here in this case. What we will do? We will recolor it. How? See, the black goes right here. So the black goes right here, and we have recolored it. There are multiple things that we can do. Either we can do recoloring, or we can do shifting, or things like that can easily happen. Okay. So in this case, okay, so this is how you do it. Okay, you see this is black, this is black, this is black, this is red. So in this case we will, so this is actually balanced, but this is not balanced. You see that red, black, oh, this is also balanced. Okay, in this case this is insert, new node is red, so here this node inserted here, right over here. Okay, then what we will do, we will fix it by coloring and 5 parent which is parent and 20 is uncle. You see that 5 is the parent and 20 is the uncle. So, recoloring both 5 and 20 black black, we are able to do this. Okay. I hope so that this is very much clear. And black can have black children and it can have one red children also. So, this is again got balanced. Hope so that this is very much clear. Okay guys, insertion with rotation and recoloring, where this is the third scenario where we are seeing when the parent is red and the uncle is black. Uncle is who? Who is the uncle here? So, let us see who is the uncle here. If I zoom in here, you see that the uncle would be this guy. This is the grandparent. This is the parent. This is the uncle and this is the child. You see, child is red, parent is red, but the uncle is black. The grandparent is also black. I hope so that this is very much clear. But in here, this condition is violating. Why? Because the child is also red and the parent is also red in this case. I hope so that this is very much clear to all of you. So, in this case, how would we resolve it? Here, what we will do? We will rotate it and fix it. So, in this case, this was the original case where black, 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 red and red. This was the violation here. So, we can just recolor it or we can just rotate it. So, in this case, this is black, this is black, black, we have recolored it both and then this has become red. Okay guys. In this case, this is another scenario where we are seeing this, that the root is black, the parent is red, the uncle is black and this is again the same thing. In this case, we can now perform a rotation where you see that first this guy will come right over here. We also have to maintain the BST property guys as well. So, do not forget to maintain the BST property also. So, in this case, this guy will come right here. So, the node looks like this and then we will again do a rotate because this is also red and red, or you can just recolor it to black in this case. But here we re-rotated it. So, this has become black and this has become red. Okay. I hope so that this is very much clear. So, all of these are the different colors. Okay. So, this is the summary of red and black trees. Okay. Recoloring happens when both the parents and uncle are red. We can just directly recolor it if the both parent and the uncle is red. Okay. If recoloring parent and uncle to black and grandpa to red, and we can do that. This is how this is gonna be red. When to do single rotation happens when the parent is red and the uncle is black. We can do one single rotation either on the left or on the right side, depending upon when to do. Performing either left or right rotation, then recoloring it to fix the violation. Okay guys. Then double rotation happens if more complex cases where the child is on the opposite side, left right or right left, and perform two rotations and recolor it to restore the balance here guys. I hope so that this is very much clear guys. Okay, let me just close this off and again bring the color to normal. I hope so that this is absolutely fine. Much clear. Okay guys, we are back. Right here we are back. Okay. Okay guys, what we have understood just now, let us revise. Code we will write later on. Okay. Black parent. Now uncle is also red and parent is also red. In those scenario, if the child is also red, then we can just recolor it. So recolor it, recolor it, recolor it, recolor it, both of them. So these are all recolored, and we can just make sure, because this is root, let it be black, or if you are making it red, then later on again it will become black. So in this case, there is no point of doing this. Okay guys, so in this case we can just say that the root is always black in this case. When I will show you the code, tomorrow's class I will show you the code, there I will explain you how this works, but actually this is very basic conditions where you know how to apply it. Still we were just talking about insertion. In tomorrow's class we will be doing some deletion also, and basic insertions, basic properties we will again revise and we will finish it off. Well, I hope so that this is very much clear. For this class, let it be till here only. We will continue in the next class, and for now I know that the theory was very more. Tomorrow's class I will just directly do one thing. Will bring you some more examples related to red and black tree with the help of actual red and black tree examples. More examples I will show you tomorrow, different scenarios I will show you tomorrow, and then I will tell you the code directly. Okay guys, so in that case you will understand this in a much more better way and in a depth way. Okay guys, I hope so that this is very much clear. Well, this was just the basics of red and black tree. In tomorrow's class, we will finish this red and black tree concept, and it will be over in tomorrow's class, max to max. Okay guys, well, I hope so that this is very much clear. If you have any doubts, please do let me know. In the tomorrow's session, I will be explaining you this in a much more better and easier way, because tomorrow's class I will make some examples and I will show you there. Okay guys, so yeah, we will talk about that in the tomorrow's class. If you have any doubts, please do let me know right now, and then we will finish up the session here. Right. We can do 5 minutes, 10 minutes doubt session. Yeah, clear. Very nice. Today not many people came, but yeah, I will give the notes of this file in the description below, and also I will put up anything which is regarding necessary for this file into one place. Well, that's all guys for today's class. Well, let us end this class. Before I end this class, I would like to request you people to please like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. Also, share this live stream as much as possible so that this live stream reaches those people who really really needs about this course, and this course is all for free. This is stretching a little bit more, but if you want, you can join our crash course which has already been started. So if you want, we can join you in your crash course session where we will finish this in just 1 month. Other than that, related to placements and more sessions related to placements or maybe internships, please follow us on Telegram channel. The Telegram link is given right in the description below. If you follow this on Telegram, you will be able to see a lot of stuff. So don't forget to follow us there guys. And yep, that's it guys. Thank you so much. I will see you again tomorrow at the same exact time, 7 o'clock. I'll see you guys right away, 7 o'clock in tomorrow's session guys. Thank you so much for watching guys. This is Ashank David signing off. I'll see you tomorrow. Till then, take care and happy learning. Also stay tuned for tomorrow's class. I'll be putting up any resources right away after this class so that you can get it directly. Okay guys.